So similarity learning is one of those specific cases of machine learning model training process that is important enough in itself to be treated as a field, a distinct field of machine learning. And similarity learning is closely related to both classification and regression. The important difference, though, is that it uses a different type of objective function. The area where similarity learning is most widely used is in recommendation systems, where basically the aim is to understand the behavioral pattern of a user, a customer, for example, and then provide recommendations of items to that user, which could be products, for example. It is also often used in solving verification problems like, for example, speech verification, face verification, and the like. Now, similarity learning treated as a supervised learning problem is basically approachable as a classification problem, which means that in this particular case, the similarity function will map pairs of entities to a finite number of similarity levels, say ranging from 0 or 1 to any number of levels. So basically this means that the similarity function is not a continuous function, but is a discrete function. And the output of the similarity model would be a certain level of similarity that was calculated, that was predicted for the inputs. It can also be treated, similarity learning can also be treated as a problem of regression. And basically in this particular case, the similarity function will map those pairs of entities, like for example, users and products, to numerical values. That's like you calculate, for example, you predict a similarity score for a certain product given a certain user or a certain customer. There is also a variation of this approach where basically the supervised form is kind of a weakened form in a sense that you don't apply an exact measure, but you apply an ordering measure. And this is known as a ranking similarity learning. And usually this approach is a better fit for real life and large scale problems. Those are the types of problems, for example, where you have to deal with millions or tens of millions of users of your website and tens of thousands or hundreds of thousands of products, and you also need to kind of produce those predictions in near real time. And that's where relaxing a little bit the requirement and going towards an ordering measure instead of an exact measure allows you to significantly increase the performance of your machine learning model.